So this is 1.5a in college algebra, and the section is called More on Functions. And what we're going to do here is, when you're talking about functions and graphing functions, you have some standard functions that look a certain way. So if you look in the very back of your book, you have on the back cover what's called a library of functions. And what that library of functions is just an idea of what a general function will look like depending on how the equation is written. So for example, you may get a function that looks like this, and that's called a cubing function. And a cubing function, third row down, first column, cubing function, it's going to look like this. Now it may actually be one that looks like that, or it may start over here and go like this, but it's got the same form as this guy there does. So what changes is maybe this thing, it's got a higher part here and a lower part here than what this one does. It could be that it's switched around. It could be instead of going through the origin, it's shifted over here, or it shifted down, or it shifted up. And that's what we're going to look at now with this one, is increasing, decreasing, and constant functions. Things are going to move around a little bit on the graph as we're doing these. So some more vocabulary. Bottom of page 119. If the graph of a function rises from left to right, it is said to be increasing. So if we are going from here to here, from left to right, it's increasing. It's increasing on that interval. Now the word interval, what in the world does interval mean? It means the space that we're talking about. Let's say that we're interested in this graph at -2 to +1. So we're interested in what the graph is doing between these two numbers. That is the interval. An interval is a vertical line that kind of separates the graph into different pieces. So it could be that we have a graph. Let me draw another one here. And the graph may do this. And maybe you're not interested in the whole graph. Maybe you're just interested in what it does between these two numbers in that interval. And you'll notice that it rises a lot here. Or maybe you're interested in what it does here between these two intervals, or in that interval where it doesn't really do a whole lot. So you pick which part of the graph you're interested in so you can make a decision and you can look and see what's going on there. Alright, so if the values stay the same from left to right, so if we have a line like that, that is said to be a constant function. It doesn't really change there. Alright, so if you have, and I'm looking just at some of the drawings they have here in the book, if you have an interval, let's see if I can get rid of some of this stuff here, or if you have a graph that looks like this, and you have this, and you're interested just in the interval from here to here. It rises from left to right from, say, -2 to 0. From 0 to 4, it decreases. Okay, so in these different intervals, it does different things. So most of the time you're going to have to say what interval you're looking at. All right, and we'll get into that a little bit more as we go through here. All right, so in that gray box in the middle of page 120, let's go ahead and read through that. It says a function is said to be increasing on an open interval. An open interval means basically that there is no line to say, okay, we're going to start here and we're going to stop there. Okay, so it's basically saying that it's increasing from left to right, but I'm not saying that it's just between here and here. I'm not saying it's just the numbers that occur between there. I'm saying it occurs on all of the numbers throughout the whole graph, from -infinity to +infinity. That's open interval, for all a and b in that interval. All right, so basically what that's saying is that it is increasing from left to right. Okay, so as this number gets bigger and bigger and bigger, what happens to the y value? It also gets bigger. So that's why it says as if a is smaller than b. So let's call this a, and we'll call that b. What also is happening is the function of a, the y value of a, is also smaller than the y value of b. So notice the distance here is smaller than the distance here. The function of a is smaller than the function of b. Okay, so that's an increasing. Decreasing means the opposite. Okay, that a is less than b, okay, which it still is. But what's happening, and we'll do this in blue here, is it's going downhill. So the function of a may be big, the distance there, so f of a is going to be big, and the f of b is a lot smaller here. So it's going to be smaller than the function of b. So these two are the same, but notice these, whoops, I got this backwards, don't I? These two are opposite. Okay, the a value is going to be bigger than the b value, or the y value for a and the y value for b. All right, and constant just means that they're the same. Your x or your y values, like I said when I had that horizontal line, the distance here, function of a, and the function of b, or the y value at a and the y value at b, are going to be the same. So we're going to have the function of a equals the function of b when a is less than b, because a is smaller than b. Okay, but their y values that are associated with them, or the function of a, is going to equal the function of b. Okay, so that is where we're at there. And if you look at some of the pictures, middle of page 120, notice that the far left one, figure 1, is increasing, and figure 2 is decreasing, and figure 3 is constant. Okay, and they give you that I distance there with the arrows there at the bottom, just telling you that it is on an open interval. It goes in, well, in these, I'm sorry, these are closed intervals because the graph stops. Okay, they don't go into infinity, so we're talking about a closed interval there. All right, so let's look at A. Determine the intervals on which the function of the figure at left is increasing, decreasing, or constant. Okay, so there is the graph. So we're interested in finding out where the graph increases. So the interval from 3 to 5, it increases, right? So that's the domain that we're looking at. So the function is increasing in the interval from 3 to 5. Okay, that's the way we're going to write that the interval there. Okay, and notice it does not have the inclusive brackets on there because it does not include 5 or 3. At 3, it's not increasing, it's just sitting there. It's changing direction. If it's changing direction, going from constant to increasing, at the point it's changing, it's not increasing, right? It's just kind of there. So it isn't including 3. And notice here, 5. This is the point where it's changing direction from increasing to decreasing. So at that apex, that point there, 5, it's not doing either. So that's why it's got the open, or I mean the rounded one, saying it does not include 5. So make sure that you know that we're not talking 3, 5 there. All right, and then B says, where is it decreasing? Well, it's decreasing at a couple different points. It's decreasing from negative infinity to negative 1, rounded, and then it's also decreasing from 5 to infinity. Again, rounded. Okay? All right, if you look at where it is, let's see, C, constant. It's constant from negative 1 to 3. And again, rounded, because those are points where direction changed, so they're not included in increasing or decreasing. All right, so in calculus, middle of page 121, I want to make sure you're aware of this, because if you plan on going any further with math, In calculus, the slope of a line tangent to the graph of a function at a particular point is used to determine whether the function is increasing, decreasing, or constant. So really what that means is if we have a graph here, and we want to know a line that's tangent to a point on that graph. Here's my tangent point where it intercepts it at one point. I can determine whether or not this is an increasing graph at that point depending on this line that's tangent. So this line is increasing, so therefore I know that this graph is increasing there. If my line was here and it went through a point there, then I know that my graph is decreasing at that point of intersection there. So that's what they're saying there. Okay, so relative maximum and minimum values. All right, let's go ahead and talk about that for a minute before we get going on another video. Consider the graph shown below. Let me take a picture of that. All right, so there's a graph there, and what we're looking at is just part of the graph here. And it's saying in the interval that we're looking at, there is a high point called a maximum, and there are two low points depending on what interval you're talking to. But those are minimum points. Those are basically how you know a minimum point is. It's the lowest part of the graph before it starts turning or changing direction. So it was low here and changed direction, and then it came down here and was low here before it changed direction again. So there's two low points. We're not looking for the lowest point. We're just looking for a low point. So we're looking at the same thing here. As it goes here, it's increasing, and once you hit a point, it starts decreasing. So when you're increasing going to a decrease, then that is a relative maximum. All right, so that's what we're looking at as far as relative maximum and relative minimum. All right, and let's just keep going here. Again, if you take calculus, you're going to use those. So let's go to example 2. Using the graph shown below, determine any relative maximum or minima. Maxima and minima are plural for maximum and minimum, because there might be more than one, of the function f of x equals da 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 da, and the intervals on which the function is increasing or decreasing. So where is, what they're asking for is determining the relative maximum and minimum and the intervals on which the function is increasing or decreasing. All right, so we could look and very obviously see that my maximum is at 2.004. That's the highest point. So there's my maximum, and there's my minimum. And as far as the interval is concerned, it says the interval in which it is increasing. It is increasing from here up to here. So from negative infinity to negative 0.082. Okay, that's where it ceases increasing. All right, now notice your increasing and decreasing, your intervals are always your x value. All right, now if we're going on where else is it increasing, we would say it's also increasing from 4.082 to positive infinity. Okay, and it's decreasing from here, negative 0.082 to 4.082. And again, open or curvy circle or parenthesis instead of a brace. All right, so application of functions. We will continue that on the next video.